Okay guys, next come to the topic of line integral of electrostatic field. So I have already discussed what is the potential. That is, I already told you that to move a point from in a field, I have to move a point from A point to B point, I have to do a external work on it. So external work, that is nothing but the potential difference I have already discussed. So now, so that is I wanted to do it in a clear manner. That is, let's suppose a point charge I have taken. So here this is I have taken the 3 dimension. In a 3 dimension I am putting the source charge. So this is our source charge, which is I kept at the origin. So now I kept at the origin. Now from this particular charge we will get all the field intensities. So I drew few field intensities here, and let's suppose the point charge, the charge was here. I wanted to move this charge from A point to the B point. I wanted to move. So I made a curvature. Why? Because I don't want to take a straight line because it is independent. I told you already, electric field is already a conservative field, so it is like a gravitation field, so it will not depend on a path followed by the external path followed to move any charge from one point to the other point in the field itself. So now, so that is what we are going to discuss now. So now from A point to B point I wanted to move here. So each point here, let's suppose this is point is located in this direction, it is having what here, electrostatic intensity. I wanted to move in a one by one in a line segment. So that is nothing but I am going to say that is a line integral of electrostatic field. So line integration, what this electrostatic field, whatever the electric intensity is there, that I wanted to move from each line segment from here to here, here to here, here to here, here to here, like that. So each segment I wanted to move. So if I just add up all the segments, this one, this one, this one, this one, if I add up, I'll get my entire integration. That is why to move from this integration from A point to B point, I have to do the dot product of electric intensity E bar dot, this is the resultant one, E bar dot the line segment is how much our distance they are moving. EDL is equal to what can I write? I have to sum it. So let's suppose what I can write, E bar dot dl, because it is having a direction, so I can write a displacement. So dl bar, similarly E2, this is E1, this is dl1, next E2 dl2, like this I have to write till for what, till I have to write for a en bar dl n bar. So till here I have to do each segment, if I add up, that will become your line integration. Okay, so this line integration is nothing but this one. So now one more step you wanted to see. I told you already what is the electric potential would be for A point to B point. This will not depend on the midpoint, whatever the midpoint you had, it will not depend. It will only depend on the starting point, the final point. The starting point is A and the final point is B. So that is why I can write electrostatic potential VAB, which is VA minus VB, must be equal to what here? Starting and ending point, I know this is a line integral. This must be equal to this point. So VAB is nothing but line integral E bar dot dl bar. This must be equal to this point. This is important. Next we are going to find each point. I wanted to analyze whether it is correct or not. I wanted to analyze. So let's suppose take a point here. So that point I am taking in this graph. This point is P here. Okay. So this point is P. If I wanted to draw a normal to this one from this particular point N, and you know already from this point to this particular point, which is you can take it as M point, from this point to the M point I have a distance of R. Okay, and this is very small segment, very small point, so I can write a dr, and this curvature is making almost some theta, which is I can take it as a angle theta. So from this graph, from this particular region only I am going to make out few things here. So what is that? So if I write from the triangle, let's suppose this is almost like a triangle. So triangle N, you can write NP, you can write this is as a PMN. From the triangle PMN, what can I write? Cos theta I wanted to write. Cos theta is equal to what can I write? Cos theta is equal to dr divided by dl. So dr is nothing but what can you write? Dr is nothing but dl into cos theta. This is one point you have to make it up. This is equation 1 you can take. Okay. Now you know already I got a one small thing. Now this electric intensity, the electric intensity due to what? The electric intensity due to this particular charge. So electric intensity also I can write a formula which is 1 divided by epsilon 4 pi epsilon naught. Again I can write a q divided by, what can I write? Q divided by the distance. The distance is from here to here. The distance I told you what O to M distance is a r square. So O to M distance is r square. This is the equation number, I can take a equation number 2. So now what I wanted to do is simply this equation, so whatever the equations I am doing here, so let's take equation 1 and 2 should be substituted in a equation where equation star. So equation star I am taking, which is VAB is nothing but what can I write? Integration A to B E bar dot dl bar. So if I remove E bar dot dl bar, what I will get? This dot product, if I remove, what I will get here? Integration A to B. If I remove dot, then I will get E bar dl cos theta. Okay. Now dl cos theta, you know, dl cos theta means what can I write here? Dl cos theta means r I can replace. So VAB is nothing but integration A to B. This dl is nothing but what can I write here? I can replace this one with what can I replace? Dr. So I can write E bar dot d bar. So E bar is nothing but you know already this thing. So I can, at the place of this one, I can write this one. So integration A to B 1 divided by 4 pi epsilon naught and q divided by r square and dr. Okay. Now again, what can I write here? Simply charge and this 4 pi epsilon naught is constant. So q divided by 4 pi epsilon naught if you take common. So what is remaining thing? 1 divided by r square, integration 1 divided by r square, which is A to B, and dr is remaining thing. You know already, if I integrate 1 divided by x square dx, if I integrate, what I'll get here? Minus 1 divided by x. This is a formula. Okay. Now if you substitute here, what I'll get here? So q divided by 4 pi epsilon naught, and I'm going to substitute this thing, then 1 divided by r here, which is limits VA, and this is nothing but VAB, electric potential difference. VAB is equal to, what can I write here? If I substitute these limits, I can write a q divided by 4 pi epsilon naught. 4 pi epsilon naught. If a minus is there, lower limit minus upper limit, I can write VRA minus VRB. You might have done this thing in a integration. So I am writing this step as a direct step. Okay. So next topic is a line integral of electric field along a closed loop. This is a small topic, but the application is important as for the IIT and NEET. Okay. So line integral field along a closed loop is, here you see here I have taken the same 3-dimension quantity. In this one I am putting a source charge at a positive charge at this one. In this entire, it is having certain field. So let's suppose if I am moving a point charge from A point to B point in the electric field of this particular source charge, so I'll get a electric potential. So along, if I write along AL1B, what is the electric potential? I can write VAB, right? So VAB nothing but VA minus VB, and the line integral I can write integration. What can I write? Integration A to B, and in the electric field intensity is E bar, and length is here, from here to here it is moving, so I can write length, I can take dl bar. So small length I am taking in the small part of it. Similarly along you can write A L2, if it is moving from B to A, so I can write BL to A. If it is moving, then the potential difference from B to A, then I can write VB minus VA is equal to, line integration comes where from B, here it is not from A to B, it is B to A, and the integral part is here to DL bar, DA bar and DL bar. Now what is the total net electric potential. Now what is the net electric potential, which is I can write a net electric potential is here. Net electric potential I have to take this one as well as this one, so you can write a VAB plus VBA. So you know already VAB and VBA is nothing but what can I write here? VAB means VA minus VB is equal to plus VB minus VA. So you simply can cut, this is a simple method. So total net electric potential on that particular loop is equal to 0. So you can conclude that the integral field you can write the integral field, so line integral, okay, integral field, so that is line integral field, okay, you have to write this is a line integral field along a closed loop is always 0. So you have to write this one, this important, very important point, the closed loop is always 0, and that is no work done in taking a unit test charge along a closed loop. So there is no work done also, so there is no work done also in a taking a test positive charge in a closed loop. So if I am bringing from here to here, I can come back to the A only. So that is why there is no work done. These 2 points are important from this topic. Okay, thank you all. Subscribe my channel and comment on it. Thank you.